We're going to be talking about angles of elevation and angles of depression. So an angle of elevation is our first little blank. And it is the angle formed by a horizontal line and a line of sight to a point above the line. So in this diagram, you'll notice we have this horizontal line right here. And from that horizontal line, I would have to go up in order to form the angle in the picture. So because I have to go up, it is an angle of elevation. Our other one that we have, actually let's do red, is an angle of depression. And it is the angle formed by a horizontal line and the line of sight to a point below the line. So in the picture, again, we have our horizontal line. And from that horizontal line, in order to get to the rest of the angle, I have to go down. So that tells me that's an angle of depression. An important thing to note in here is that they both have a horizontal line. So a horizontal line is needed. And you'll see why when we start actually applying them to problems, why we need that horizontal line. So since the horizontal lines are parallel, since all horizontal lines are parallel, angle 1 and angle 2 are going to be congruent by the alternate interior angles theorem. So if you look at the picture, we have our angle 1 and our angle 2. And then if you don't see that alternate interior angles, remember you're always looking for that little z, like that. So looking at angle 1, remember this is, we have to decide is it an angle of depression or elevation. So from my red horizontal line, in order to make angle 1, I would have to come down. So it is an angle of depression. So then for angle 2, looking at it, if I'm at my horizontal line, so you always have to refer back to it, in order to make angle 2, I have to go up. So it's going to be an angle of elevation. And they're going to be congruent to each other, which is going to help you when you start problem solving with problems later. So with this one, we're just going to be classifying the angles as angles of elevation or depression. So with angle 1, I see my horizontal line, and to get to that other one, I have to go down. So then I know that that is an angle of depression. Angle 2, I look from my horizontal line, I would have to come up. So then that would be an angle of elevation. Use a different color. So then for angle 3, again, looking at that horizontal line, I'm going to have to come down to make angle 3. So that's going to be another depression. Oops, why do my S's look funny? And then for angle 4, our horizontal line is the lake. And in order to make angle 4, we have to go up. So it's going to be an elevation. And so remember, you're always referring back to the horizontal line. So for example 2, we're going to do the same thing. So angle 3, I notice I have this horizontal line up in the sky. And so I would have to come down. And because it's down, it is a depression. And if you want, feel free to pause the video at any point to try and practice questions on your own. So angle 5, we have this horizontal line. And so in order to make angle 5, we would have to come down. So it's going to be another depression, or angle of depression. And then for angle 6 has this horizontal line, and to make it, we have to go up. So it is an angle of elevation. So the actual use of these is whenever you are doing mostly word problems. So looking, we have the Seattle Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? So, and we're going to be rounding to the nearest meter, and that's always important to know how you're supposed to be rounding. So it's always good to draw a picture. I personally like to add little touches to them so that they're more entertaining to look at, but you don't have to. You can just draw a regular triangle if you want. But we have our Seattle Space Needle, and we know that this Space Needle casts a 67-meter shadow. And then we are going to be going from the tip of the Space Needle to the tip of the shadow. So if you can't quite see it, our triangle is going to be the little section I'm highlighting, and we have this right angle down at the bottom. So because we were talking about the angle of elevation from the tip of the shadow, that's kind of your hint that we're going to be looking at the bottom of the shadow. Notice we have this horizontal line along the bottom, and we have to look up. So that tells us we're looking at our angle of elevation, and that is going to be 70 degrees. And then because we are looking for how tall the Space Needle is, that means I need my vertical height. So I'm just going to put an X there. So then this is going to be a lot like what we did in the beginning when we started with trig. You have one unknown and you're going to have to solve for it. So we're going to have to pull out our SOHCAHTOA. And looking at this, my X is my adjacent, or not my adjacent, my X is my opposite because it's across the triangle. So remember, opposite is all the way across. And then adjacent should actually be a part of the angle that you're talking about. So 67 is my adjacent. So because I have opposite and adjacent, you're looking for that O and A. So I know it's going to be tangent. So we're going to have tangent of 70 equals opposite over adjacent. And then to finish solving this, you would just have to get the X by itself. So we'll multiply both sides by 67. And then you have 67 times tangent of 70 equals X. And then you use your calculator to get that value. So you'd have 67 times tangent of 70. And that gives you 184.08. But remember, we wanted nearest meter. So because it's 184.08, that would just round down to 184 meters. Okay, so then our next one, we're going to be talking about an airplane. So again, I like to draw little pictures because it makes it more fun for me, but they're not very good most of the time. So we have a plane, and we know it has an altitude of 3,500 feet. And it has an angle of elevation from the airport to the plane is 29 degrees. And we want to know the horizontal distance between the plane and the airport, and we're going to be rounding to the nearest foot. So I got a little excited because I want to draw my picture. But we have a plane and an airport. And so because we know the plane's altitude is 3,500, we're just going straight down from the plane is 3,500 feet. And then our angle of elevation from the airport, again, your key thing is that it's saying from the airport, it is 29 degrees. And I know that's angle of elevation because I'd have to go up in order to actually draw the angle. And we want to know the horizontal distance. So notice they're not saying the direct distance between the airplane and the airport. They just want to know how far is that distance from the plane to the airport if you were just going across the ground. So again, we're using SOHCAHTOA. So 3,500 feet, I notice, is my opposite side, and X is my adjacent side. So again, we're going to be using tangent. So tangent of 29 equals opposite over adjacent. And so to solve this, we would have to first multiply by X on both sides to get it out of the denominator. So X times tangent 29 equals 3,500. And then you can divide by tangent 29. So that goes away. So then when you do 3,500 divided by the tangent of 29, you get 6,314.17. So rounding to the nearest foot, I see this little 1 is telling me to round down. So it's going to be 6,314 feet. So if you have a little voice in your head that tells you that that answer must be wrong because it's too big of a number, remember that we're talking about an airplane to an airport, and that the height of the airplane was 3,500 feet. So it's kind of, your answers will be relative to the numbers you're given based on the situation. So don't always just say an answer is wrong because it's too big or too small or anything like that. Okay, so our next one, we're going to have an angle of depression. So suppose a ranger standing on a ledge 90 feet above the ground sees a fire, and the angle of depression to the fire is 7 degrees. What is the horizontal distance to the fire round to the nearest foot? So we have 90 feet above the ground, angle of depression is 7 degrees, and we want to know horizontal distance rounding to the nearest foot. So looking at this, notice in the picture, if you are the ranger, your line of sight is this horizontal line. Now remember, you have to have a horizontal line in order to have an angle of depression or elevation. So we know this is a depression because we're having to look down to the fire. And if you notice with this, you have this cute little Z in here, don't you? So because we have that Z, we know that we have alternate interior angles. So I know this angle in here is 7 degrees. And some people will also see this as the triangle over here, and they'll draw the picture and label the triangle on the top. But if that doesn't make sense to you, don't worry about it. If it does, you can use it. So in order to do this, we have, let's see, 90 feet is our opposite side, and X is our adjacent because it's right next to it. So again, with SOHCAHTOA, we're still using tangent. And tangent's probably going to be the most common one we use, simply because we don't generally care about the direct distance from the plane to the airport. So just make sure you're reading carefully on which part of the triangle you should be looking for. But we're doing tangent of 7 degrees, so that we're referring to that angle is opposite over adjacent. So then to solve this, we're going to multiply both sides by x. Boop, boop. And then we have x times tangent 7 equals 90. So then we will divide by tangent of 7. And x equals 90 divided by tangent of 7 is 732.99. So again, nearest foot, we are going to have 733 feet, like that. So one thing to note, because 733 does seem like a big number, given that we had a 90, your angle of your angle of elevation is actually going to get bigger the closer you are to the object. So if you think about it, if you're standing and you see a plane out in the distance, if you're just looking straight ahead and then looking up to the plane, you're probably not going to have to look that far up. But if you have a plane directly above you that you're trying to see, you're going to have to look up a lot farther before you're able to actually see the plane. So that angle of elevation should be bigger if the number or if the object is closer, and should be smaller if it's farther away. So we have an ice climber standing at the edge of a crevasse that is 115 feet wide, and the angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. And we want to know how deep is the crevasse, and we're going to round to the nearest foot. So if you don't know, a crevasse is kind of like a canyon, so to speak. It's like a big giant crack in the ice. They're not normally this perfect looking. There's probably a lot more to it. But remember, we're just looking at straight down and straight over. So from straight down and straight over for this crevasse, because we know it's 115 feet wide, we have it on the side. And then you're going to have to draw straight from there, from that edge, down to the other corner. And you notice that it is a dotted line because they're talking about the edge. So we want to have that dotted line just because it helps you kind of see that your angle of depression is right here. And so that angle is 52 degrees. So because we know that angle is 52 degrees, that means that we know this angle down here is also 52 degrees because of alternate interior angles. So because we want to know the depth of the crevasse, we're going to be looking for that tall side. So again, we're using tangent because it's our opposite that's across the triangle and the adjacent. So we have tangent 52 equals opposite over adjacent. And so we'd have to multiply by 115. And when you have 115 times tangent of 52 times tangent 52 equals 147.19. So again, nearest foot, it's going to be 147 feet tall. Okay. So our next one, by this point, hopefully you're able to do it on your own, so you can always try it. But we're going to have an airplane, and he is flying at an altitude of 4,500 feet. Now we have an angle of depression from the plane to a control tower that is 15 degrees, and we want to know what is the horizontal distance to the tower, and we're going to round the nearest foot. So I have my little plane, I have my little control tower, and so straight down from the plane and straight over to the control tower, because my altitude is 14,500, that's going to be this left side of the triangle. And then my angle of depression, remember, you're looking from the perspective of the plane. So from the plane, your line of sight is just straight out. So to make that angle of depression, you're going to have to go down. So this angle is 15 degrees, not 52. So because we know that angle is 15, then we know this one down here is also 15 degrees because of alternate interior angles. So then to find our horizontal distance, we just have to set up another trig problem. So 14,500 is my opposite all the way across, and x is my adjacent. Adjacent. So then we have tangent of the angle we're talking about. Tangent of 15 is opposite over adjacent. So then we're going to multiply both sides by x. So we have x times tangent 15 equals 14,500. And then we divide by the tangent of 15. And we have x equals 14,500 divided by tangent of 15 is 54,114.7. So because we're rounding to the nearest foot, this 7, remember 5 and above, give it a shove, it is now 54,115 feet. And even though that may seem like a big number, remember that's only about 10 or 11 miles or so. And so if you're in a plane that's up 14,500 feet, you can see 10 or 11 miles because that's like standing at the top of Pikes Peak. So you can see really far out, even though that seems like a humongous number. So with the next one, it's a little bit different because we have 2 points of interest now that we're looking at. So we have a forest ranger that is in a 140-foot observation tower, and he sees a fire moving in a direct path towards the lake. The angle of depression to the fire is 3 degrees, and the angle of depression to the lake is 8 degrees. And we want to know what is the distance between the fire and the lake, rounding to the nearest foot. So looking at this, if I'm looking at my fire, and actually let me color coordinate this nice and pretty. If I'm talking about my fire, that would be that little 3 degrees in there that we're talking about. So because that angle is 3 degrees, I know that this one down here is also 3 degrees. Then for my other one, we're going to have this entire space, and that is 8 degrees. So because that one is 8 degrees, we know that this one is also 8 degrees. So in order to solve this, we are looking for this little piece of this big triangle. And notice that the big triangle is all the way from the observation tower over to the fire and back up. Because in order to use all this trig, we have to make sure we have that right angle in there. So when we're doing this, I know I'm going to want to know the distance from the tower to the lake. And then there's actually 2 different ways you can do this. You can either see this as its own entity, like z, or you can break down the lake from the tower to the lake and then the lake to the fire as 2 separate things and call it y. And I'll show you both ways so that you can see how they both work. So starting off, we'll just do it with the z. So we're going to first find the distance to the lake. So just looking at that little triangle, I have 140, an x, and an 8 degrees. So that means I'm going to be using tangent because I have my opposite and my adjacent. So let me get rid of my little picture. we have tangent of 8 equals 140 over x. So if you haven't noticed already, we're going to actually just be swapping these positions. And I just have been calling it algebra magic because it helps me kind of see how they swap. So notice that the x and the tangent just kind of swap places. So then we have 140 divided by tangent 8, and that is going to give us x equals 996.15. So then, because we have that value, now we know that this little distance in here is 996.15. And I usually go out 2 extra decimal places to help with any rounding issues that I might run into. So then, to find the distance from the tower to the fire, we're going to do the same thing, except now it's going to be tangent of 3 degrees equals 140 over z. So then, through your algebra magic, you multiply the z to both sides, then you divide by the tangent of 3. You end up with 140 divided by the tangent of 3. And when you do 140 divided by the tangent of 3, you get that z is 2,671.36. And so that means that my entire distance from the tower to the fire is 2,671, and from the tower to the lake is 996. So to find the distance in between, you would just want to subtract. So 2,671 minus 996.15 is 996.15. 1,675.21. And so then rounding to the nearest foot, we know that it is a distance of 1,675 feet. Okay, so then our last two. So example 9, we have a pilot flying at an altitude of 12,000 feet, sights 2 airports directly in front of him. The angle of depression to one airport is 78 degrees, and the angle of depression to the second airport is 19 degrees. What is the distance between the 2 airports? Round to the nearest foot. So we have our airplane. Boop. And then we have 1 airport and 2 airports. And for me, it's a little bit easier to just kind of draw the lines and then label what it is. So airport 1, airport 2. So because he is flying, remember we're looking from the perspective of the plane, my angle of depression to my first airport is 78 degrees. So because I'm going all the way down, it is 78 degrees. And remember, the closer an object is, the higher that angle of depression or angle of elevation should be. So then for the other one, we have an angle of depression of 19 degrees. So because I know that angle at the top is 19 degrees, I know that this angle down here is also 19 degrees because that angle of elevation and depression is going to be the same. You just have to make sure you're putting it in the right spot of the triangle. So then we know that the pilot is flying at 12,000 feet, and we want to know the distance between the 2 airports. So this is going to be just like the one above, and I'll do it the other way so that you can see if you like that way better than the Z. So we're going to have X and Y. So in order to do this, we're going to first find our X. So we're going to do tangent 78 equals opposite over adjacent. And so we're going to have to do our math magic. We're going to multiply by the X, divide by the tangent, so that we get 12,000 over tangent 78. And then X divided by, 12,000 divided by the tangent of 78 is 2,550.68. So now I know that I have that piece. I have 2,550.68. So then if I'm trying to find the distance to the other airport, I'm going to look at 19. So instead of using Z, this time I'm going to have tangent of 19 equals 12,000 over, and instead of z, I'm going to have x plus y because it's this piece plus this piece. And I already know my x value is 2,550.68. The reason why I like doing it this way is because it kind of helps keep you from accidentally not subtracting that 2,500 later. So you still do the same thing. You'd be multiplying by the 2,550.68 and then multiplying that by tangent 19. And then you would have to divide by the tangent of 19 to both sides. But notice it doesn't actually change how you do it. So we have 2,550.68 plus y equals 12,000 divided by the tangent of 19 is 34,850.53. And then we subtract our 2,550.68 from both sides. And we have y equals minus 2,550.68. And you get 32,299.85. So then we're still going nearest foot. We would be 32,300 feet. And if you were doing this like we did above, instead of having this 2,500 plus y at the bottom, you would just have your z. So then your z value would actually be this number right here. And then this number would still be your x value. So you'd still have to be subtracting those numbers regardless. So whichever way you prefer is totally up to you. I'm fine with either. So our last example, there is a woman standing 12 feet from a sculpture. So we have our woman, and we have this beautiful sculpture in front of her. So we know that the angle of elevation from her eye to the top of the sculpture is 30 degrees, and the angle of depression to the base is 22. How tall is the sculpture to the nearest foot? So looking at this, remember, this is her eyesight. We know that she's 12 feet away, and because she looks up, our angle of depression or elevation is 30 degrees, and when she looks down, her angle of depression is 22 degrees. So we want to know how tall is this statue. And if you notice, we have two little pieces because both of these triangles are right triangles. So we can't just do a trig with these angles over on the left. We actually have to do two separate things. So we're going to start with the x. So we're going to have tangent of 30 equals opposite over adjacent. So then we'd have to multiply by 12. And 12 times tangent of 30 is 6.92 or 93, I'm sorry. And then to find y, you do the exact same thing, except now it's tangent of 22 equals opposite over adjacent. So again, multiplying by 12. So then 12 times tangent of 22 will give you y. And that is 4.85. So then to find the height of the statue, we're going to have to do x plus y because it's both pieces. So that would be 6.93 plus 4.85. And when you add those, you get 11.78. So then, because we're rounding the nearest foot, that 7 tells me to round up. So it is 12 feet tall. So if you have any questions, feel free to ask, but the homework is listed at the bottom. And let me know if you have any questions.